write H naught matrix in a diagonal form. Then we have to find what is W dash in a matrix form. And then you will see that W dash is not diagonalized. Then you have to diagonalize W dash. So each and everything we have to do what we have discussed earlier. And always try to remember that degenerate perturbation theory you can only solve when you can represent each and everything in a basically matrix form. So this is very interesting. But before going to that problem, let me go for one integration. So I hope you know this integration, but I am just going to recap this because this integration will come again and again this problem. So look at this is very interesting. So what we have, let's say we have this integration that will be 2 by a. I have deliberately taken 2 by a because the normalization factor, and this will be 0 to a by 2, and this is sin pi x upon a, and you have sine 2 pi x upon a dx. So this is not 0, okay? Neither one, because this is 0 to a by 2. If it is 0 to a, then it is 0. There is not any problem. So how you will approach this thing? You will just approach 0 to a and 0 to, sorry, 2 by a, 0 to a by 2. You will just open it. So you have sine square pi x upon a and cos pi x upon a dx. We will multiply with 2 here. So 2 is there. So what you will do, you will next step, you can just go for sine pi x upon a is equal to t. Then you have pi by a cos pi x by a is equal to dt into dx is equal to dt. So I can easily substitute cos pi x upon a dx is equal to a upon pi dt. So what we have, so x is equal to 0, then t is equal to 0, and x is equal to a by 2, then t is equal to 1. So this integration will go to something like 4 upon a, and here integration is 0 to 1, and you have t square dt, and a by pi will come outside. So what will be this value? This is a very simple one, and this value can be written as 4 upon 3 pi. So this is the answer. Okay. So we will use this integration again and again into this particular problem. So if you have any doubt, you can just ask me. Otherwise, you can go for sine A into sine B also. So I have difficulty to remember formula. So I used to go for the first principle, but you can use that formula also. Okay. So this is the integration we are going to use. So let's go for some one very beautiful problem, and this will be a problem for the degenerate perturbation theory. So let's go for this. Is that okay?
Sir, wait.
Yes.
Sir, wait.
Acha. Okay. Should I go for? It's okay.
Done, sir.
Okay. Okay. Now, what is real problem? Look at. So what we have v x y z. So this is three-dimensional potential is equal to 0 when x is between 0 to a, y is between 0 to a, and z is also between 0 to a, and infinite otherwise. So which type of potential is this? Particle in three-dimensional box. Okay. So infinite other way is perturbed with potential, and let's say this potential is HP, and it is given V naught when x is between 0 to a by 2 and y is between 0 to a by 2 and 0 otherwise. प्लीज म्यूट कर लो, किसी का अनम्यूट है ना? So this is your potential. What you have to do? First question is very trivial. Find the first order energy correction in ground state. Second, find the first order correction in first excited state. This is very interesting. So now, please tell me what will be your first state ground state? What is the energy eigenvalue for first state ground? Ground state. What will be energy eigenvalue for the ground state for this system? That will be, that will be En is equal to, or this is nothing but nx square plus ny square plus
Plus
nz
NZ
square.
square.
We have done all this thing into E naught. Remember, E naught is nothing but pi square h cut square upon 2ma
Two.
square. So what is the ground state? The ground state is easy, and that will be 1 square plus 1 square plus 1 square E naught. That will be 3 E naught. And this is degenerate or non-degenerate?
Degenerate, sir.
This is degenerate. Where is
Yes,
degeneracy? This is non-degenerate. So what is the
non-degenerate, sir.
eigenvalue? So this is E111. What is the eigenvector? E psi 111. And this value is equal to 2 by A sine pi x upon A, 2 by A sine pi y upon A, and 2 by A sine pi z upon A. This is the eigenvector, and 0 otherwise. This will between x, this is between this particular thing. So for the ground state, you will use degenerate perturbation or non-degenerate perturbation. For the ground state, you will use degenerate or non-degenerate.
Non-degenerate, sir.
Non-degenerate, because this is non-degenerate. So let's go for calculating the ground state. So what should be the E1111? This is energy correction in a ground state. So that will be psi 111 HP psi 111. That's it. So we have to just go into write into the integration form. So first, so V naught will be there. This is 0 to a by 2. This is 2 by a sine square pi x upon a by 2, and dx is always there. 2 by a sine square pi y upon a dy 0 to a. This is a by 2, because it is this perturbation is all about between this, isn't it? And this will be 2 by a sine square pi z upon a dz. Okay. Now, can you please tell me what will be this value?
1 by 2.
1 by 2.
1 by
Very
2.
good. So this will be 1 by 2. What will be this value? 1 by 2.
1 by 2.
What will be this value?
1.
1.
1. 1.
Very good. So that value v naught by 4 is the answer. Okay. ये भी एग्जाम में आ सकता है, don't worry. So this will be your first order energy correction in a ground state. We have easily used this particular ground state thing, and we can see how we can go for this. Okay. Let's go for next level. Next question is very interesting, and you need to do a lot of calculation into this. Not lot of calculation, but same type of calculation again and again. So if you will approach smartly, then you can easily get this value. Now, let's go for a first excited state. So what is your first excited state? The first excited state, you can have E211, that will be 6 E naught. E121, that is also 6 E naught. E112, that is also 6 D naught. Isn't it? And these all are same, so they are what? Triply degenerate. This eigenvalue is associated to psi 211. This will be associated to psi 121, and this will be associated to psi 112. Isn't it? And what is this psi 211? This will be root 2 upon a sine 2 pi x upon a and root 2 upon a sine pi y upon a. Here is root 2 upon a sine pi z upon a. Isn't it? Similarly, we have 2 upon a sine pi x upon a root 2 upon a sine 2 pi x upon 2 pi y upon a and 2 upon a sine pi z upon a. And similarly, we have third one. So this will be 2 upon a sine pi x upon a 2 upon a sine pi y upon a 2 upon a sine 2 pi z upon a. Okay. So this is 2 pi, this is 2. Okay. This is 2 pi z upon a. Now, so what should be the degeneracy? What is degeneracy? This is triply degenerate. Now, and the eigenvalue of each particular eigenfunction is same. So now, what is my first duty? What is my unperturbed Hamiltonian? Unperturbed Hamiltonian is all about particle in a box. And what is perturbed Hamiltonian is given as V naught, where x is given 0 to a by 2, y is 0 to a by 2, and 0 otherwise. So this is given. Now, please tell me, what will be H naught diagonalize in a matrix form? Can you please tell me? What will be H naught diagonalize in a matrix form?
Yes, sir.
What will be that?
सर डायगोनल होगा ना ये सर?
हाँ, तो क्या होगा उस डायगोनल एलिमेंट क्या होगा?
सर जो हमारे क्या बोलते हैं 5 1 स्टेट 5 1 5 2 0 जाएगा और 5 1 5 3 0 जाएगा और 5 2 5 1 0 और 5 2 5 2
तो क्या डायगोनल टर्म होगा क्या? ओके ठीक है,
6
डायगोनल
0
टर्म होगा क्या?
6 0 0
6 E naught 6 E naught 6 E naught, isn't it? So if you will operate H naught here, what you will get? 6 E naught. You will operate H naught here, what you will get? 6 E naught. You will operate H naught here, you will get what? 6 E naught. And all these thing is orthonormal. So what we will get? You will get the diagonal matrix for H naught. So I can define my H naught as something like 6 E naught 0 0 0 6 E naught 0 0 0 6 E naught. So you can just write this thing as, for the convenience, you can write this thing as, let's say I am writing this thing as phi 1, I am writing this thing as phi 2, I am writing this thing as phi 3. Can you please tell me what will be this element? ये कौन सा element है? How you will get this one?
Sir,
Phi
5
2.
2 5
No,
2.
no. This you will get phi 2 H naught phi 2. Isn't it? Matrix element. So H naught will operate on phi 2. It will give 6 E naught. Phi 2 is 1. So this will be 6 E naught. What will be this element?
Sir, 1 3.
1 3. So this will be phi 1 H naught phi 3. H naught will operate on phi 3. What you will get? 6 E naught. And you will get phi 1 phi 3. So this will be 0. So similarly, we have calculated all the elements of H naught, and we have, the beauty of Schrodinger wave equation is that the solution of Hamiltonian or energy eigenstate. So in a basis of, so Hamiltonian in a basis of energy eigenstate is always diagonalized. So what we have done, we choose a wonderful basis, and that basis is nothing but the solution of Schrodinger wave equation from the postulates 5. That is energy eigenstate. So Hamiltonian is 100% diagonalized into basis of energy eigenstate. So what we have done, we have written H naught D actually. And we have written H naught D with this principle. So I am putting it here. So I have get this particular H naught D. Now, and this will be some 6 E naught 0 0 0 6 E naught 0 0 0 6 E naught. Now, what is the next target? Next target is that we have to write W in a basis of in which H naught is diagonalized. This is the thing. We have to write W in a basis of in which H naught is diagonalized such that we can find W dash. W dash can be diagonalized, W dash cannot be diagonalized. There is not any problem. So let's go for how you can get W dash. So how you will get W? So how many element in this W dash? How many element will be there? Can you please tell me how many element will be there?
9 element.
9 element. So how many element you have to find? You have to find 9 element, isn't it? So once
Yes.
you will get the 9 element, then you will get the W dash. Okay. So we will just find 1 or 2 element, and then you can easily get the thing. The same type of integration will again. So what will be W dash 1 1? So W dash 1 1 is all about phi 1 W phi 1, isn't it? Phi 1 W phi 1. So this is your, so let's go for integration, and please you can use the pencil. Okay. So what will be first term? V naught phi 1 phi 1. So you will take the phi 1 here. So you will just go for 2 by A sine square, or I can write something like this: 2 pi x upon A sine 2 pi x upon A dx This will be 0 to a by 2. Next is 0 to a by 2. That will be 2 by a sine pi y upon a sine pi y upon a dy, and you have last here 0 to a 2 by a sine pi z upon a sine pi z upon a dz. Okay. Okay, so what will be this integration? First integration, can anybody tell me?
Half, sir.
Half.
1 by 2.
Very good. What will be second integration?
1 by 2, sir.
1 by 2.
Into 1.
What will be third integration?
1.
1. So what you have first term is w dash. The first term of w dash is v naught by 4. Okay. Let's go for 1, 2 and 1, 3. Then we will write each and everything. Okay. So this will be your, just a minute. Okay, so let's go for w dash 1, 2. So I am putting 2 here. So this will be 2 here. So this is first will be for 1 and second will be for 2. So how it is going to change? This 2
Sir,
will be,
excuse
yes,
me, sir.
yes.
Sir, in first integration, second term is sine 2 pi x by a. Repeat.
अरे यार 1 1 दो बार लोगे नहीं?
Sir, then it will become the sine square 2 pi x by a.
अरे भैया तो इसको मल्टीप्लाई कर दो, साइन स्क्वायर नहीं होगा?
Okay.
क्या है ये? Anyway, मैं क्यों इस तरह लिखा हूं अभी समझ में आएगा. Because I want to save my time and energy. Look at here. Now next term is 1 and 2. Okay. So this is phi 1. So phi 1, this is phi 1. The first term is this one. So phi, this 2 pi x is there, pi y is there, and pi z is there. So this is this thing. The second term will be phi 2. So for second term it is phi 2. So it will be sine pi x. So I will remove this 2. Okay. And here in y you have 2. So you have to just remove this particular pi. You have to just remove this thing and you have to just go for 2 pi y upon a dy. And third term will be, then both have same pi z pi z. So this will be same. Now, so why I have written this type of thing. अब समझ में आया क्यों लिखा है ऐसा? Because बार बार मुझे मिटाने की जरूरत नहीं पड़े. I can take a pencil and I can do it easily. Now, can you please tell me what will be this integration? अभी तुरंत किया था.
4 by 3 pi.
Very good. This integration is 4 by 3 pi. What will be this integration?
4 by 3 pi.
4 by 3 pi. Very good. भाई आपको एग्जाम में करना है, 1 घंटा टाइम थोड़ी लगाओगे. What will be this integration?
1, sir.
1. 1. So this will be, you have 16 upon 9 pi square v naught. Let's go for 1 3. Let's go for 1 3. So this will be, I am just going for, this one is 3. So what will going to change? So first will remain same, then first will be 1. So 1 will remain same. I am not going to change 1. What I am going to change? The third one I have to take. So this is pi x by a. It's okay. Here pi y by a. So I have to change this one. This will be pi y upon a dy. And here, this will be 2. So you remember, this will be phi 3. So this will be, you have to convert it at 2 pi z upon a dz. Okay, what will be this integration? Can anybody tell me? What the first integration is? 4 by 3 pi. The second integration is 1. And what about third integration?
4 by
Anybody?
3 pi.
1
Arre,
by 2.
0, 0. This is between 0 to a.
Oh,
This is normalized, orthogonal, 0.
Yes, sir.
Isn't it? आप समझने की कोशिश करो मैथमेटिक्स को जब तक फील नहीं करोगे एग्जाम में नहीं होगा दिस इज जीरो because this is 0 to a by 2, so why we are doing this integration, but we know that these two are orthonormal, so this value is 0, isn't it? So you can just get this value is 0 into 0, this value is 0. Okay, so similarly you can calculate all different stuff and you will be surprised that always you will have W dash as a symmetric matrix. So there is not any problem. I am just writing what will be W dash. So you can just do the practice with yourself, but I am writing directly what will be W dash. The same type of integration will come again and again, and you will get this particular W dash. And once you will do this three thing, everything is very okay. So W dash, and I am writing directly. So this will be H naught D plus W dash. H naught D is all about 6 E naught, 0, 0, 0, 6 E naught, 0, 0, 0, 6 E naught. Can you please tell me what will be your W dash? The W dash will be V naught by 4, and this will be 16 V naught upon 9 pi square 0. This will be also 16 V naught upon 9 pi square. This will be V naught by 4, 0, 0, 0, V naught by 4. Because it is symmetric matrix, and if you will calculate this thing, the diagonal term will be always V naught by 4, V naught by 4, and this thing your W dash. Now you can see this is your diagonalize, this is your non-diagonalize. You have written W dash in a basis of this particular thing, and it is non-diagonalized. So what you have to do? You have to again diagonalize this thing. So once you will diagonalize this thing, what you will get in the diagonal term? What you will get in the diagonal term? Can anybody tell me what will be the diagonal term? If you will diagonalize W dash, what will be in diagonal term? The eigenvalue. The eigenvalue of this matrix will be come into the diagonal term. So what you have to do, you have to just calculate the eigenvalue of this particular matrix. So let's calculate the eigenvalue. So you will calculate V naught by 4 minus lambda 16 V naught upon 9 pi square 0, 16 V naught upon 9 pi square, and this is V naught by 4 minus lambda 0, 0, 0, V naught by 4 minus lambda. And what you will get? You will get one value is V naught by 4 minus lambda. Another value is V naught, and this will be something V naught by 4 minus lambda whole square minus 16 V naught by 9 pi square whole square must be equal to 0. So you can just calculate this particular thing and you will get the answer. So what will be the answer? One value is lambda is equal to V naught by 4, and here you can do this a square minus b square. So second is V naught by 4 minus lambda plus 16 V naught upon 9 pi square and must be equal to 0. And then this value, and next one is v naught by 4 minus lambda minus 16 v naught upon 9 pi square. So here lambda is equal to, you can get v naught by 4 plus 16 v naught upon 9 pi square. And here is v naught by 4 minus 16 v naught upon 9 pi square. And this will be v naught by 4. So this is, let's say, lambda 1, lambda 2, lambda 3. So you will get the eigenvalue of W dash, and you are 100% sure that if you will diagonalize, this eigenvalue will be in the diagonal term. So what should be the final answer? What will be change in correction? What will be correction term? So these are the correction term. These are the correction term, and triplet degeneracy is going to break. So let me go for a final answer. Up to that, are you comfortable?
Yes, sir.
And there is not anything that you can avoid. You have to do calculation. You have to do calculation. Okay. So let's go for a finally what we are getting. So initially we have E naught as my eigenvalue, 6 E naught before perturbation. After the perturbation, it will break into 3 parts. The first part will be something 6 E naught plus V naught by 4 minus 16 V naught 9 pi square. Next level is all about 6 V naught plus V naught by 4, and next level is all about, so दिखाई दे रहा है ऊपर, so that will be, just I am writing it in different way क्योंकि हर एक ऊपर चला जाएगा, है ना. So this will be 6 E naught, and this will be break into 2 parts. The first part is 6 E naught plus V naught by 4 minus 16 V naught upon 9 pi square. Second level is 6 E naught plus V naught by 4. And third level is 6 E naught plus V naught by 4 plus 16 V naught upon 9 pi square. So this will be, the degeneracy is going to break. But what will happen? Every level is going to little bit higher than 6 E naught. So this is the answer. So you can see how much calculation you have to do. And this type of problems coming into your exam. So you cannot avoid this calculation. So break the inertia of calculation. But thing is that how smartly you can approach the problem. So doing one calculation, just do the another one. This is the most important thing. And you can find how we can get all this stuff. So let me go for our next problem. Okay. And this type of problem is bound to take the time. So you have to be very conscious in exam that whether you have to attempt this problem in first attempt or second attempt. So always try to go for the easy question first. And this type of problem you can go for in the last, even if you know this type of problem, what you have to do. But you can see this is taking a lot of time. At least it will take 10 to 15 minutes, isn't it? And you can expect some new problem. So this is also very important. Anyway, so let's go for one more problem. And again, the calculation is going to involve. So we cannot avoid the calculation. So much better that you can use the pencil and eraser into your calculation. What is this thing? This thing is, let's say H naught is defined as px square upon 2 py square upon 2 plus half x square plus y square. So what is this? This is a harmonic oscillator with m is equal to 0 and omega is equal to 0. Okay. So this is deliberately given that you cannot trap unnecessary calculation into for m is equal to 0. Sorry, m is equal to 1 and omega is equal to 1, not 0. This is 1 and omega is equal to 1. So both we have taken 1 unit and we can just solve it. Okay. Now, what is the perturbation? The perturbation is very interesting. That will be V naught x and y. So this is some kind of perturbation is there. What you do? You need to calculate first order correction in first excited state. First order correction in first excited state. So can you please tell me, and it is also given the first order wave function such that you can just go for. So first order wave function is 1 0 and this will be 2 upon pi 1 by 2 x e to the power minus x square plus y square by 2. So it is given 1 0. So what will be 0 1? So what is your first order energy? Can you please tell me for the two-dimensional harmonic oscillator, what are the first order energy? E nx ny, you can write nx plus half h cut omega plus ny plus half h cut omega. So this will be n plus 1 h cut omega, where n is equal to 1 2 3 and n is equal to nx plus ny. You remember all this thing? And what is value? Sorry, n is equal to 0 1 2 3. And what is value of ground state? The ground state is E00 and omega is 1 unit. So I can put E00 is equal to h cut. And what will be first excited state? 1 0 is 2h cut and E01 is 2h cut. So what we have? We have first excited state by putting omega is equal to 0. Okay. Sorry, omega is equal to 1, not 0. Omega is equal to 1. So we have first excited state is doubly degenerate. So for the first excited state, we have to go for, in which method? We have to go for what? Degeneracy method, degenerate perturbation theory. So how you will go for degenerate perturbation theory? So first you have to write what will be your H naught. So okay, I can take this one as my phi 1 and what will be my phi 2? Can anybody guess what is phi 2?
501.
501. So what will be that value? What will be that value? Let's say this is phi 2 psi 01. Can you please guess me what will be that value? That value is 2 upon pi to the power half y e to the power minus x square plus y square by 2. Okay, just from the symmetry. You remember use of Hermite polynomial? This is h1x, here is h1y, h0x is h0y is 1, h0x is 1. So this is the all term. So now please tell me what will be your h naught? Can you please tell me what will be your h naught in a diagonal form?
2h cut 0 0 2h cut.
Very good. That will be 2 cross 2 matrix. So I can use this space and h naught is 2h cut 0 0 2h cut. Very good. How you can get this thing? You will operate h naught here. H naught phi 1. What is energy eigenvalue associated to this? H cut. Because omega is 1. What will be energy eigenvalue associated to this? Is h cut. because omega is 1. So you have h naught phi 1 is equal to h cut phi 1, and you have h naught phi 2 is equal to h cut, sorry, 2h cut phi 2. So you can get this matrix, and this matrix is what? H naught D. Now, what is your perturbation? The perturbation is very interesting. This will be HP V naught XY. So what we have to do, and this is W. W is nothing but XY. So what you have to do, you have to represent this XY in a basis in which H naught is diagonalized. So H naught is diagonalized in a basis of phi 1 and phi 2. What we have to do, we have to write W dash in a basis of phi 1 and phi 2. And it is not necessary that they are diagonalized. They may be diagonalized, they may not be diagonalized. So let's calculate how many elements we have to calculate into W dash.
4, sir.
4 element, because this is 2 cross 2 matrix, and the space is created by these 2 vectors. So we have to go for 4 matrix. So let's go for 4 matrix. Okay, and then we have to go for a integration term. Okay. Okay. So first term is W dash 1 1. What do we have to do? Phi 1 W phi 1. And x is between minus infinity to plus infinity, y is between minus infinity to plus infinity. So let me go for this integration. So what will happen? This will be 1 1. So I have to take this one. Okay. And W is there. So you have to go for double integration. One is, so 2 upon pi is there. And this will be 1 is x e to the power minus x square y square upon 2, and this will be xy, and here is x e to the power minus x square y square by 2 dx dy, isn't it? So 2 bar upon pi I have deliberately, or you can take something like this also, 2 upon pi. Okay. Now let's go for integration. So what we will do, we will just take x part together and y part together. Okay. So what will happen for x part? So
Sir, V naught also.
V naught is there. V naught ko to le hi lenge. W dash 1 1. So you can take 2 upon pi outside. Integration from minus infinity to plus infinity. X and x is x cube e to the power minus x square. This and this will come. So this will be x square dx. And here is, you have y minus infinity to plus infinity e to the power minus y square dy. What will be this integration? Can you please tell me what will be this integration?
Gamma
इतना टाइम क्यों लग रहा है? अरे जीरो. This is odd function. Minus infinity to plus infinity, minus infinity to plus infinity. This is 0,
Yes, sir.
isn't it? This is 0. So first term you have W dash is equal to 0. Let's go for second term. कहीं ये भी 0 ना हो जाए तो सारा खेल ही खराब हो जाएगा. Anyway, are you comfortable up to this?
Yes, sir.
Yes, sir.
Yes. So I have to give 1 2. So I always request you to use pencil. 2. Here is 2. So what is going to change? Here y is going to change, isn't it? So here x square is there. Here y square is there. Okay. So we have to just use the gamma integral now. अब आप gamma integral को use कर सकते हो because they are even function, they are not 0. So what you can do, you can just go for, and v naught is also there. So I am writing this thing as, कहाँ लिखूं? It's a very difficult. चलो इसका भी use कोई खास नहीं है. I can use this one. So you have 2 upon pi V naught, and this will be 2 into 1 by 2, first integration, and that will be gamma 3 by 2, isn't it? Because यहाँ पर कोई भी coefficient नहीं है, so this will be gamma 3 by 2. Second, this is your first integration. The second integration 2 into 1 by 2, and this will also gamma 3 by 2. So what you will get, बाद में लिख लेंगे इसको, 2 upon pi V naught, this going to cancel out. So you have first term will be half into root pi, and second term will be also half into root pi. Okay, because this is cancel out. So this root pi is cancel out. This 2 and this 2 is cancel out. I think this value is V naught by 2. So just check whether I am correct or not. I think this value is V naught by 2, isn't it?
Yes, sir. Correct, sir.
Correct. Okay. So now, can you please tell me what will be 2, 1?
V naught by
sir.
V naught by 2, because यहाँ y हो जाएगा, यहाँ
Yes, yes.
again same thing will be there. So that will be V naught by 2. What will be 2, 2? 0. Isn't it? When you will take 2, 2, in spite of x, you have to take y, then this will be 0. So what we have, you can just calculate all these things. So we have this particular integration, and we have matrix, and that matrix is H naught D as 2h cut 0, 0, 2h cut, and plus you have this particular thing 0, V naught by 2, V naught by 2, 0. This is your W dash, and you can again see that W dash is not diagonalized, and it is diagonalized. So it is not necessary that in which basis H naught is diagonalized, W dash is also diagonalized. It is not necessary. So you can just see how we can approach this particular thing. So what will be the eigenvalue of this particular matrix? So what is the final solution? Should I write the final solution? So the eigenvalue of this matrix is V naught by 2 and minus V naught by 2. So initially before the perturbation, you have 2h cut, and after the perturbation, it will break into two part. One is 2h cut plus V naught by 2, and here is, sorry, this is minus V naught by 2, 2h cut plus V naught by 2. This type of question can easily come into your exam because calculation is not very heavy and concept is always there. Okay, so this will break into two part, and I am just talking about omega is equal to 1 and m is equal to 1. So this will be the thing. Okay, so this is a next problem. Let's go for one more. Okay, then we will finish it. Are you comfortable?
Yes, sir.
Okay.
Yes, sir.
So hydrogen atom in ground state is perturbed with potential. Let's say this is lambda s dot l. आप इसको करोगे भी, G-man effect and all other places. So lambda s dot l. So for the ground state means n is equal to 1. Find the correction in energy. Find the correction in energy. For 2 के लिए भी कर सकते हो. Find correction in energy. For n is equal to 1. So by the way, n is equal to 1 means what? N is equal to 1 means what? L is equal to 0,
Ground state.
ground state, and S is also there. So what will be this? So 1 1, and this will be two part. One is plus half, and sorry, 1 0, and you can take 1 0 and minus half, isn't it? Yes or no? Spin is also there, so we have to account the spin. So this will be divided into two parts. So there is doubly degenerate if I am including the spin, because it is written that Hamiltonian is S dot L. S dot L is nothing but the spin. So can you please tell me what will be your H naught matrix? How many? What will be dimension of H naught?
2-dimensional.
Two-dimensional. And what will be energy related to this one? Just tell me what will be energy related to this one?
E naught 0 0 E naught.
What is E naught? Minus 13.6, isn't it? Because energy is only dependent on n is equal to 1, and you have two space. So you have basically minus 13.6, 0, 0, minus 13.6. Okay. So this is your H naught. And now you have to find S dot L matrix. You have to find S dot L matrix. How you will get the S dot L matrix? You can just go for lambda J square minus L square minus S square by 2. Remember? And L is equal to 0 and S is equal to half. So what will be value of J? How many value of J is there? So what will be the
1 by
eigenvalue? So that will be J is equal to J into J plus 1 into L plus 1 minus S into S plus 1 H cut square by 2. Now L is equal to 0, S is equal to half. What will be value of J?
1 by 2.
1 by 2. So what will happen in this problem? There is every element is going to, because n is going to change. So n is remain same, and if you will calculate all the value, for how many value you will get from here? Only one value, isn't it? J is equal to what? Half. So this will be 3 by 4 h cut square minus 0 minus 3 by 4 h cut square, and this will be lambda. So this will be 0. So what you have HP matrix as 0 0 0 0, isn't it? Because there is no other option, because L is equal to here, L is equal to 0, S is equal to half, and L is equal to 0, S is equal to half. This is SZ. This is SZ. This is L is equal to 0, S is equal to half for everything. So what you will get, you have not any correction in the ground state. You have not any correction in the ground state due to this coupling. But yes, you will find the correction into first excited state when I will tell L is equal to 1 and S is equal to half. Then how many value is there? 2 value we have done into your LS coupling and all this thing. So you will do this thing into your this atomic physics. I am just giving you a glimpse how you can approach it. So it is not necessary that your perturbation is your degeneracy is going to break down. It will depends what is your basically potential. So there is not any correction. There is not any correction. You can figure it out. So this is worthless for the ground state. But yes, it will be very worth for the first excited state. You remember what will be the energy for the first excited state we have get?
J equal to 3 by 2 पुट करेंगे सर फर्स्ट के लिए.
J is equal to 3 by 2 you will put, isn't
Yes.
it? And as well as J is equal to half. So 2 value you will put. Because once I will put L is equal to 1 and S is
3 by
equal
2
to
1 by
half,
2.
then J is equal to
3 by 2 1 by 2.
half as well as J is equal to 3 by 2, and then you put it here, and then you will get two basically different value. But then H naught is not two-dimensional. Then H naught is higher dimensional. N is equal to 2 means you have a big number of this particular thing. Okay. So I am just giving you just simple example, not unnecessary tough example. So you have to always go for a step by step and approaching the thing very nicely, and without calculation don't try to tick the answer. Okay, try to go for the calculation. And yes, in the perturbation, mainly degenerate perturbation, the calculation is fully involved, and everything what we have done into our core part, mainly postulates, mainly all different type of potential, we are going to use this thing. Okay, so on this particular note, we have finished our approximation method. Okay.
Excuse me, sir.
Yes, बोलिए.
सर सर स्केटिंग का सर कैसे पढ़े सर स्केटिंग प्रॉब्लम?
स्केटरिंग अभी मत पढ़िए, एग्जाम के बाद पढ़िएगा. ठीक है, अभी जितना कर रहे हो उतना कर लो, नहीं हो पाएगा अभी, है ना.
ठीक सर.
ठीक है. So listen, you have to just go for the easy question. Okay, so I will do scattering but after your paper, because you have asked me that you need at least 1 week for revision. So scattering will take at least 3 classes, and it is not necessary the problem will come or not come, and every problem is tough, so not it is very easy problem. Okay, so scattering, so we have only two, mainly 3 thing is there. One is basically time dependent perturbation, another is scattering, and another is relativistic quantum mechanics, and all the 3 are the very fringe topic. So it is not necessary that they will ask question, and even if they will ask question, it is the one of the toughest one. Okay, so but up to this you can see the toughness level is going increase each and every day. Okay, so in this particular moment I can do only this part of thing. Okay, such that you can just go and do easy question, because if you will give me 1 more week I can able to finish the course, but you have told me that you need break such that you can at least revise this thing. Okay,
Okay sir.
so are you getting this thing? So if you have any more doubt, anything you need to say. So after the exam we will just finish it, and we will also do all different type of problem, doubt session, everything we will do after the exam. Okay,
Excuse me, sir.
because yes, हाँ.
Previous year question papers में कुछ doubts हैं, so I can WhatsApp you for questions.
कर दो, हाँ कर दो, उसमें कोई प्रॉब्लम नहीं, उसका सॉल्यूशन भी तो होगा आपके पास, नहीं है?
Sir, actually ना approach करने में प्रॉब्लम जा रही थी कुछ क्वेश्चंस को. Okay then.
तो चलो ठीक है, तो मुझे भेजो, बिकॉज मैं किस तरह से आपको, क्योंकि बिकॉज यू हैव सॉल्यूशन, तो सॉल्यूशन तो बना हुआ रहेगा. अनलेस अंटिल वी हैव नॉट कन्वर्सेशन इट इज वेरी डिफिकल्ट टू गाइड यू. ओके, आप नया क्वेश्चन है तो मैं सॉल्व करके दे सकता हूँ. एनीवे यू कैन सेंड मी, लेट्स सी हाउ आई कैन टैकल इट. ओके,
Yes, sir. Okay, sir. Thank you.
आप उसको भेजो एक बार, है ना, तो आप उसको भेजो और इस
Yes,
तरह से भेजो कि कहाँ पर आपको डाउट है ना.
yes,
So
sir.
just you can
Okay,
just try to just circle it, and then
Yes,
I
sir.
will try to figure it out कि किस तरह से हम बात कर सकते हैं. ठीक है?
Okay, sir. Okay, sir. Thank you.
Okay. हाँ.
Thank you, sir.
Okay, so just go and do this all thing again, and try to do previous year problem. Okay, you will see that all problem, at least 90% problem you can able to apply all this theory. Okay, thank you.
Thank you, sir.